Well, hello guys, welcome back to John's Workshop. This is episode 19 and this is going to be the making of the drawbar for the new Cormak Milling Machine. So this is, I'm trying to get into a new mode of videos now, so this is just going to be purely focused on just the making, the design and the making of the drawbar. There'll be a bit of overlap with one of the previous episodes where I've spoken about the drawbar, so apologies for those that watched that before. Just fast forward that bit if you don't want to watch it. But I'm just trying to transition now from doing multiple things into just being a little bit more focused on the videos and trying to shorten them down a bit. So just before we start that today, we'll focus in on the bench a little bit more and we'll do a little bit of a workshop update. We've got my very first viewer mail has come, so we'll open that and have a look what's in there. And then we'll do a quick workshop update and then we'll crack on with the drawbar. So we've got some viewer mail that's come in this week, so thank you very much to Carl, really much appreciated. So on one of my previous videos I was talking about removing the top of the head of the milling machine and getting into the gearbox to see what state that's in, you know, in terms of the casting sand and everything else that we've seen on previous episodes. So one of the items that I mentioned that I needed to get was a decent set of circlet pliers, because I don't have anything like that at the moment. So Carl very kindly offered, he'd got a spare set and he offered to send me. So I know what's in the package, but I've not seen them yet, so we'll open that up. So that came earlier in the week, on Thursday this week. So we'll just get into that and have a quick look. Very well packaged. Well, there we go, as good as brand new. A set of proto circlet pliers that are just spot on for what I need to get the circlip off the top of the spindle. So Carl, really much appreciated, thank you very much. So very first viewer mail, and you'll see those in action in the next 2 or 3 weeks when I strip the head down. So thank you. It's a big help at the moment. Obviously, anybody who's been watching all of the episodes will know that I've been spending quite a bit of cash recently in terms of buying a mill and buying various other bits and pieces along the way as well. So it's just one less thing that I need to fork money out for. So brilliant. Okay, in other news, and this is related to the episode, the new drawbar that I'm making today is it needs some biggish size threads putting on it. I didn't have the right dies that I needed, so I've ordered some taps and dies for the whole drawbar thing. So we've had an M16 die arrive and an M14 die that's arrived, and they came from Arc Euro Trade. I thought we'd try them out. Until we've tried the dies, I can't tell you how good they are. And an M16 tap as well that I'm going to need to rectify the face mill that I've got and the drill arbor that I've got to put an M16 thread in the back. So we'll get into the weeds of those. Yesterday, once I'd looked at the dies, I realised immediately that I didn't have a die stock to hold the M16, the biggest one. And I didn't film this, and I really should have done, I suppose, because it was an interesting project. But I got a bit of bar end that out of my scrap box, and I've basically made a die stock to hold the M16 die. The two handles, again using what I've got. When the mill arrived, it had some big long coach bolts that were, I'll just get the end of it, that were holding the mill to the pallet. So basically I've just chopped the end off the coach bolts, off 2 of them, and I've turned those 2 coach bolts into the handles for that die stock. So I've now got a die stock to hold that. The M14 die, I did have a die stock, it was my dad's. It's probably not been used for at least 40 years, if not longer. It was absolutely red rusty, it had got a couple of screws missing, so we cleaned all of that up, and so that's now ready to go as well for the M14 thread. I'll just cut here and spin you around to a quick workshop update, what I've been up to during this week, and then we'll crack on with the drawbar. So the first thing, those that have been watching the other episodes will know I've ordered a engine hoist to help me with the lifts on the mill and future lifts of various different things when I move or whatever I need to move around. The good news is some of the lifting gears arrived. The bad news is not all of the lifting gears arrived. So it's box 2 of 2, box 1 of 2 is still yet to turn up. So all I've got at the moment is the very base section and the casters. So I'm still waiting for the big arm, the long arms and the legs to turn up, which hopefully will come at some point this week. So next week's episode will be all back around the mill again and around finally positioning it. And on that note, I'll just spin you around and show you what I've been up to in preparation for the mill this week. So you can see here, guys, this is the static phase converter. It's in position now. It took some lifting up there, by the way. That's about 30-35 kilograms as a unit, so quite heavy. So basically I've created a shelf, and the reason I've stuck it as far up as I can is because it's going to be sitting roughly behind the mill, and I don't want to be blowing swarf and coolant and oil and stuff all over it. So I've tried to stick it as high as I can so it's out the way from swarf and coolant, but it's also not taking up valuable space on the floor or on the wall lower down. What I have done, and you'll see here, I've used almost an all steel construction for the leg support. So this is 50 by 50 box section. It's off centre, you'll notice, and that's been done deliberately to try and maximise the space at the mill. And you'll see already, dual purpose. I'm thinking around 2 or 3 things with this 50 by 50 box section that I've used. Originally I was going to use wood, and then the more I thought about it, I got this box section left over from the bench build, and I thought, no, I'm going to use that. As you can see there, I can stick my mag bases on it so they're out of the way. Also, I'm thinking, obviously, one of the future purchases is going to be a DRO for the mill, and what I'm thinking is, rather than screwing the DRO actual reader unit, the sort of readout unit, to the mill itself on an arm, I shall screw it to this this leg. So it's there sort of in readiness. It's also steel, it's very sturdy. I can fix other things to it, I can weld other things to it, I can make shelves, brackets, whatever I want to do. Now that's in place, it's a very useful support that I can use for all kinds of things. One thing I had considered doing, and I may still do this, it'll have to mean taking the phase converter back down for a small time, is actually drilling through sideways sets of holes all the way down. So a big hole in one side and a smaller hole in the other at an angle for all my Morse taper 4 sleeves and various things. It's an option. It's not an easy option, but it would make a good project for the mill. I can tip the head over at the right angle and drill the holes. Potentially I might do that, or I might just weld steel outriggers, if you like, onto that and make some nice wooden shelves that sit in underneath here, out of the way, so they're protected from dust and crap falling on them, and I might have everything set underneath there as almost a series of shelves down underneath with all my tooling on. So it'll evolve over time, I'm sure. But that's all powered up, so it's all wired in. Switch it on. It makes a thud as it obviously kicks in, but that's all ready to go now to provide 3-phase power to the mill, or any other machine that I decide I want to use 3-phase in the future. So that's good. What I'll do now is we'll move to the lathe. No, we won't. We'll move to the whiteboard, and I'm just going to discuss quickly the drawbar design again. So if you've watched this bit in a previous episode, I think it was either 16 or 17, just skip past this bit, and I'm going to make it fairly brief anyway. So for those that haven't seen this bit before, here's the drawbar in the top of the mill. So this is an M12 thread on one end, and it's just got a welded nut on the other end. The bore all the way through the spindle is 14.3 millimeters. So obviously this, as this sits inside the spindle, you know, there's quite a lot of rattle in there, which will cause an amount of imbalance when the spindle's running. At the speeds I'm running it, the imbalance won't ever be a problem. You need to be above 4,000 revs really before balance really becomes an issue. But either way, I think we can have something a bit more sturdy than that, and also all of the Morse Taper 4 accessories, or the majority of them, have an M16 thread on the end, and this is M12. So that's another reason that I'm changing the drawbar, so that it suits what's commercially available in large quantities. So I'll just whip to the whiteboard now, and I'm just going to go back over the design again that we're going to make, and then we'll crack on with the actual making. So apologies for the camera flicker, guys. I know it's going to be bad at the moment. It's on the shopping list of things, and at some point it will be getting fixed. So bear with me for now. So I've done a quick drawing of the drawbar. So it's going to have to be loaded from the bottom upwards. So basically this is going to be made out of a single piece of stock. So we have an M16 thread on the bottom end. One of the guys who views the channel, and apologies again, I've forgotten your name, there's so many comments that I just forget who I've responded to, but very kindly sent me an email with some photographs of his own drawbar where he's done a similar thing. On his drawbar he'd used a parallel piece of stock and actually welded a bush on the bottom, whereas I'm going to be turning this from solid, so it will make an interesting project, I hope. So what I've done is I've modified slightly the sketch based on his drawing, and to leave an extra 5 millimeters of stock at the back of the threads with a conical transition down to the 14 mil diameter, so that as you undo the drawbar, basically because the tape is locked in the spindle, the drawbar will rise up, and this extra stock here will then bottom out in the top of the spindle, and it will almost auto eject the Morse taper, so there'll be no need for a hammer, you know, knocking on the top of the drawbar, which is the traditional way to free off the tapers. So you'll see there, it's basically going to have an M16 thread at the bottom. It's going to be turned down over its whole length, and then at the other end there's going to be an M14 thread, and I shall use two nuts together on there to lock that at the right length at the top edge. So that's what we're going to make today. My stock's arrived to make this. This is a bit of spare. I've actually got the bit cut at the lathe that we're going to use, so if I make a mistake I can have another go at it. So this is 16 mil diameter, and it's 303 stainless, so I've decided to go with stainless just to make life more challenging than it probably needed to be, but it was at a good price, and I thought, well, we'll make it out of something decent quality. And I was looking at EN8, EN16, EN32, and this was the same price. Actually it was slightly cheaper than some of the EN32, so I thought we'll have a crack in stainless and see how we get on. My reservations are this biggest thread, this M16. I'm not quite sure how well that's going to go in stainless, but we'll give it a shot. Okay, so we'll move to the lathe now, and we'll start getting set up to manufacture the drawbar. So we're at the lathe, guys. Here's the stock, cut to the right length, ready to go. So basically, first operation, we're going to face one end, centre drill it, and then we're going to pull the stock right out. We're going to hold on a small section in the chuck at that end, which will end up being the M16 thread, and we're basically going to turn the rest of the thing all the way across its full length down to 14 millimeters. We're going to use the travelling steady, which is something I've never done on this lathe, and also I've never turned anything sort of longer than 3 or 4 inches, 100 millimeters away from the chuck, so this will be a real good test for me of how well the lathe is over its full, and it will be over its full capacity. The tailstop's going to be right at the end of its limit, or even if not hanging over the edge of the bed slightly to do this. So hopefully that will be an interesting project. It's going to be a learning curve for me. The last time I used a travelling steady was back in 1988, I think. So bear with me if I make any faux pas along the way, but I'll show them if I do. Couple of things with this lathe. I'm learning more and more about it. I've not used it much, I've got to be honest, since the day I bought it. I've done just some small projects here and there, nothing too challenging really. Obviously I did the die stock yesterday that I showed you, which is very basic really, just turning, boring and chamfering really. There's nothing too fantastic, and it was all close up to the chuck. This has got power traverse on it, and what I've done yesterday was changed all the gears at the end, the change gears. One of them's got a tooth missing, a nylon one, so on the tumbler gears, so I'm really not sure how well this is going to work today. We might have to kill the power feed and do this all by hand, so we'll see how we go. But one thing I've noticed with it, and if anybody's come across this before, I'd be really keen to understand what your experience is. When I turn the very bottom gear down here on its own, so not linked to any of the other gears in the train, which turns the gearbox, which turns the feed shaft, it'll turn and it's fine and it's free, and it will just keep turning and turning, and there doesn't feel to be anything binding, so it all feels okay. When I engage power feed on this lathe, so if I engage the power feed lever and turn that wheel myself by hand, it will turn about a turn and a half, and then it starts to tighten up as the carriage starts to move. So there's nothing wrong with the feed shaft itself, there's nothing wrong with the gearbox in here, but in the saddle where it engages on the feed shaft, there's something in there that's not quite right, because as everything tightens up, what it means is, as you come to knock the power feed off at the end of the cut, it's quite stiff to get it out of power feed, so that there's something not 100% right in there. So if I try and engage the power feed without the lathe running, just put that down in the right position, it engages. Doesn't really work without it switched on. There you go. So there's nothing wrong with the actual mechanism that engages and disengages, so I know it's not that. I think it's actually where the drive is taken off the feed shaft. So if anybody's experienced anything similar, please let me know in the comments what you think that might be, because either way it's going to be a full carriage strip down to get to it to fix it, I'm guessing. So alright, without further ado, we'll crack on. I'll probably do a time lapse now of the machining element, and I'll bring you back when we're setting up the travelling steady. Just before we go to the time lapse, guys, as a bit of a tip, if you're doing anything like this where you've got a long length of bar that's going to go through the headstock, obviously if it's sticking out the headstock at the back, you need to be careful how far it's sticking out. In this case it's only just sticking out, so there's no problem, it's not going to whip or cause any bother. But just in terms of loading the bar, what you would typically do, you know, if you, well, right or left-handed, it makes no difference. You'd have the chuck key in your left hand, you'd put whatever bit of bar you're putting in the chuck, and then, you know, anybody who's worked a lathe will know you feel the grip to get it running true. In this case, I'm going to have the bar right the way up close to the chuck to face it and centre drill it. It's very difficult to lift the weight of the bar, so you need to swap hands at this point, and the best way of doing it is to, if the bar's sticking out the back of the spindle, which in my case it is to do the sort of wiggling and jiggling with your left hand, and close the chuck key with your right hand to get the same sort of feel that you know you've got the bar centrally located in the chuck jaws. So, and when you first spin the lathe up, you'll be able to see at the back where it's sticking out, if it's running concentric or if it's not. So that's just a tip for anybody who's never done that before. I'll cut to the time lapse now, and we'll crack on. guys, I'm going to have to draw stumps on the travelling steady and using the full, in fact more than the full length of the lathe. I just cannot get this to cut without vibration, and a really bad vibration to the point where it sounds like the machine's going to self-destruct. It's the same kind of noise I get when I'm trying to part off. I've loaded up the old tool post, the original one that came with the lathe, and I've put a piece of high-speed steel in with a nice sort of 45-degree approach and a very small stoned radius on it. Slowed the speed down and had a go with that. It's no different. The vibration's horrendous. So I'm now beginning to wonder. I know I've still got a flatness issue on this surface here, but I'm now beginning to suspect spindle bearings. The noise is just, it's really bad. So there's something not quite right with this, and it's not safe to continue with the noise it's making. So we're going to have to pull stumps on this one, I'm afraid. So we're going to take the travelling steady off. We are going to feed the bar way back into the chuck, and we're going to attack this in two halves. You know, the 14mm diameter piece that goes down through the spindle of the mill, it's not in contact with anything. So if there's a slight transition where the two, I'm going to do it in two halves, or I'm going to attempt to do it in two halves. But certainly trying to turn at this length, it's just not happening. It's unsafe to continue. So I'll strip it down. We'll reset up, and we'll have another crack at it in two portions and see if that's any better. Right, another thought process. I'm not beaten that easily. What we're going to do is eliminate this chuck. So I'm going to take the chuck off, and we're going to load the 4-jaw chuck up, which has had very, very little use, if at all. And we'll load it back up in the 4-jaw at full length. We'll put the travelling steady back on again, and we'll give it another whirl with the 4-jaw, because at least then that eliminates any jaw gripping problems or any issues that there might be in this chuck itself. So it's a process of elimination, guys. I'm just going to keep working at it. We'll give that a crack. If that doesn't work, I'm going to revert back to doing it in two halves, as I said earlier. Oh, well, we're back, guys. It's beaten me. So two things are fundamentally not working. So turning at full length with the travelling steady just isn't going to work. The vibration, and you won't have heard it on the time lapse, but the chatter, I thought the whole thing was coming out. If I'm honest, it was that bad. So it's not the chuck. So we've established at least that much. I'm really now leaning towards the spindle bearings. There's inherent vibration when I'm parting off, when I'm doing anything like this, sort of turning. There's something not quite right. So I've stuck the 3-jaw back on. It's still making a racket, but it's safer now. So that's the first thing. The second thing is trying to use that power feed. That's dangerous. I don't know whether you saw in the time lapse, but when everything went pear-shaped, I couldn't disengage it. So I don't fancy working up towards the chuck with that kind of thing looming over me. So I'm just going to disengage all of the gears, and it's manual turning. So it's going to be lots of burnt fingers, I think, by the time we get to the end of today. But we shall soldier on. It's it is turning now. It's still making a racket, but at least it's turning. So I'm going to manually turn half and half, and we'll stick that back on time lapse, and we'll crack on with it. Well guys, I don't mind admitting it, that's been an absolute nightmare. Anyway, by hook or by crook, we've got there. I had to end up doing it in 3 sections, and even then I was still getting vibration, and I've tried high speed steel tooling, I've slowed the speed right down, everything I can think of to try and fix the vibration and chatter. I've had the travelling steady back on, but rather than at the front position, at the rear position, you know, well behind the cutting area, just to see if that helped with some extra support. And it doesn't matter what I've tried, there's something inherently wrong with this, and I'm not quite sure where it is, and I suspected it when I was trying to part off before, if I'm honest. There's something not right. It could be spindle bearings. There's obviously the issue that I spoke about with the power feed. I've got my suspicions of this tool post unit. I know I've got out of flatness on this top of the compound, so this lathe needs either the easy option is selling and buying something new, but that's not going to happen. So it needs to be stripped. I need to give it some thought and try and understand what the issues are. But long story short, drawbar is complete. So we've got a 14mm ish diameter up the middle bit. It's 14mm at the end where the threads are going to go, and obviously this end is 16mm because that's the bar stock size. So what I thought was going to be the easy bit has turned out to be the difficult bit, and now we're going to do what I thought was going to be the difficult bit, which is try and put the threads on. So I'll put that back on a time lapse, and we'll start with the smallest one. We'll start with a 14mm thread on this end, see how we get on, and then we'll spin it round and we'll see if we can get the 16mm thread on this end. If it starts getting difficult in the lathe, I might start the threads off, and then I'll take the thing out, stick it in the vise on the bench, and I'll finish it off where I can get, you know, working around it easier. So we'll see how we get on with the threads. Well, that's one end done, guys. That's the M14 thread done. Very good, actually. There's hardly any play in there at all, so it's made a nice thread. But oh God, it was it must have been a long time since I've done stuff like this. I don't ever remember it being that difficult. Anyway, that die, like I say, it was from our Euro trade. It's not a split die, so there's no way of adjusting it. Otherwise it would have been a lot easier. I could have opened it right up and gone down in 2 passes, but it's straight to size and it's stainless. So anyway, that's the smaller one of the 2 done. So I did try holding the drawbar in with the soft jaws, but there's just not enough grip. It just needed so much grip. It was never going to work in the lathe either. It was spinning in the chuck jaws as well. So it's handwork it is for the remainder. So if I can get the M16 thread on the other end, happy days. We're we'll be about there then. We'll be about finished. So I'll bring you back when we're doing that. Right guys, there's the M16 thread done at the bottom end of the drawbar. I've just got my ER32 collet holder that's got an M16 in the back, so we'll just try that. It's a good fit. So I'll kill it there, and we'll just go and try and fit that to the mill and see how it fits in the mill, up the spindle, see whether the lengths are correct. What I've done is I've made the M14 thread at the other end a lot longer than it needs to be, so that I've got some lateral adjustment to get it at the right height. So let's see how we get on. I will go and I'll stick the camera near the mill and we'll go and have a look and see if it all fits. Okay, the moment of truth. Let's have a look. Yeah, I'm not going to be able to get that in. Just I'll bring it back in a moment. I'm going to need to wind the head up to give me enough room. I think, yeah, I'll need to wind the head up, so I'll just do that and I'll bring you back. Okay, let's have a look. Well, that's a good start. It's a good fit. We'll just drop one nut on here for a minute just to hold it. Right, we'll just grab another nut. Apologies for that, just rifling around for tools. No, that's not going to work, obviously. Nice it is. I've got them together. Perfect. This into if I can. It's a low gear. Well, it looks to be a decent fit for a first go. We'll just try and undo it and see whether it self-ejects. Put this back into low. Good catch. So yeah, that's ejected the taper already. So that must be really tight. That must be really tight on the back of the M16 thread. We'll just have a look and see if we can see if it's marked it. I can't see any. There's no bruising on the back. You'll see I've left a plain diameter there, and I've put a 45 degrees on the back just to so that when that undoes, that goes up to the top of the spindle and auto ejects the taper. So we'll try that in. Obviously in motion once we've got the thing assembled properly and on the stand. But anyway, so that's the making of the M16 Drawbar. I think it's going to be okay. It needs a bit more time just playing around with it, make sure it's set up correctly. But you can see what I was intending there. So hopefully that's going to be an improvement over the M12 one that came with it, and also obviously being M16, everything, you know, like this ER32, which is a new item actually that came this week. You can buy Chinese import ones, you can buy really expensive ones, and I managed to find just this one item in the middle that's come from Germany, price range wise. So I'm hoping that it's going to be a decent quality item. It certainly looks and feels decent quality anyway. I've looked all over it. It does look to be well made. So, but yeah, like I say, everything M16 now that I want to buy will fit that drawbar. So, so we'll leave it at there for this week. So, apologies, it's been a bit of a trial by Denford Viceroy lathe. I really need to do some thinking about that lathe, and I think it's probably going to need a total strip down and to have a look and see probably new spindle bearings in it, and just check everything else out, saddle off, check the power feed bit of the saddle, and just generally give it there's something inherently wrong in there at the minute, and I just can't put my finger on what it is, but it's you know, it's not been easy, but we've managed to manufacture what I wanted to make, so we got there in the end. Okay, we'll leave it there for this week, and so thanks for watching, thanks for subscribing, and I'll catch you all on the next episode.